What's up, y'all? My name is Pepe, or at Albert J. Black on social media. Today, we're not gonna have a computer science video, but a math, a calculus video that's helpful to every engineer, computer scientist, and everyone in this planet. And today, we're gonna go through integration by parts. Keep in mind that this video won't go on how to solve regular integrals, but only integration by parts, which is a really useful kind of solution process that you can go through if you want to solve an integral. As always, a little sidebar here. We're going to go over the simple rules of the integration, so that if you don't know them or if you don't remember them, this video helps you as well to remind yourself of how to integrate so that you can do it by parts. However, if you don't want to stick around for this part because it's too basic for you, you can go ahead and continue watching the integration by parts part in this video. These things are the base things for integrals, for integration. There are a lot of more formulas that you need to know and memorize if you want to be able to solve integrals in a fast and efficient way. These four things are not the only things that you need to know about basic integrals, but they will help you out for the purpose of this video. We're gonna solve one problem for each of the formulas, so that you can have a base understanding and knowledge of the integration process. We're gonna solve this integration by applying this formula. The integral of u to the power of n, which is the exponent. In this case, u would be x and n would be 2. Would be the integral of u raised to the power of n plus 1 over n plus 1. It's not as complicated as it seems. Actually, it's really simple. Look. The integral of x squared will be equal to x raised to the power of 2 plus 1 over 2 plus 1. Which will be equal to x cubed over, sorry for the bar, over 3, which is equal to 1/3 of x cubed. Keep in mind that both of these notations are right, and it's up to you how you write your solution. The next thing we're going to solve with the integration formulas is the integral of 1 over u, where the integral of u raised to the 1 negative. It's actually kind of tricky because you would think, oh, okay, I can just apply the power rule, right? And say the integral of u to the minus 1 would be equal to u minus 1 plus 1 over minus 1 plus 1. But check this formula out. We have an error here. So I want you to look at it. Can we divide by minus 1 plus 1? No, we cannot, because this is 0, and that would give us an undefined variable. So as always, mathematicians came together and they decided to come up with this formula, and they decided to tell us as well, hey, forget about the power rule for this kind of scenarios and use this one, which says the integral in this example of 1 over x squared is equal to the natural log of the absolute value of u, which in this case u would be x squared, and an answer would be the natural log of the absolute value of x squared. You might not know what e is. E is just a value, it's a constant that we use a lot in math. Its value is actually kind of like pi, so we just name it e. In this case, the integral of e raised to an x amount of power will be just e to the x. That's it. For example, e to the x equals e to the x. There's nothing much to it. Our final example for the purposes of this video would be the summation or subtraction of an integral. So you can split it out to make the process less tedious. For example, we can say the integral of 3x plus 7 is equal to the integral of 3x plus the integral of 7. Also guys, I just reminded myself that each time you write an integral, the actual formulas have to be involved with dx or du or d the term that you are using. For example, I messed up here, so yeah. The term dx just allows us users to know which thing we're going to integrate. For example, if we had the integral a dx, and a is not a constant, but a term like x, we cannot integrate this. So always remind yourself to put d on the term you're integrating. In this case, du because we're integrating u. In this case, dx because we're integrating x. Okay, now that we have been all catched up here, we're gonna solve this integral. The integral of 3x plus 7, which as I mentioned can be split out to make the work easier and faster for you. So, we split this integral into two other integrals. The integral of 3x dx, remember dx is just referring that we're integrating x, and the integral of 7 dx. We're just gonna go ahead and solve these two integrals. Now that we have solved both of them, we can just get them together and solve the final integral. And that would be our final solution. I know this process is complicated at first, but if you want to know more about integration and you want to be the master of it all, just comment down below, "Hey Pepe, let me know more about the integration, man," and I will help you out. But you have to subscribe and like this video. Whew, that was tedious. And these videos come with a lot of love from me to you. So if you like them and you're enjoying yourself, please subscribe and like this video for the YouTube algorithm. This formula came to be known as the integral of integration by parts. Because here we have a multiplication. And how do you integrate a multiplication? That is the holy formula for integration by parts, which states the integral, come on marker, help me out here, the integral of u times derivative of v is equal, let me remember the formula, to u times v minus the integral of v du. Yeah, I know, but I'm gonna explain it to you, so don't worry, chill, get some popcorn, and watch this video. The trickiest thing about it is to choose the right u and the right dv. All you want to do is make your life easier as a computer scientist, engineer, or whatever you want to be. So, what you want to do is choose the right u and the right dv. Else, your job might be a bit more complicated than you wanted it to be. We want u to have a derivative that's easier. So I'm going to have to do this equation 2 times so you can know which derivative is easier. We're going to have to choose u equals cosine of x. And du, which is the derivative of u, derivative of cosine of x, minus sine of x. Yeah, that one. As you can see right now, probably this is not going to be the best solution. In some cases, neither is. But the derivative of u is harder, it's more complicated or the same as complicated as cosine of x. But just for simplicity and to explain it out to you, I'm going to do it this way and then the other way. We also have to choose the right dv, which is the derivative of v. At first, v is unknown because we have to integrate dv to get v. So, since we choose u to be cosine of x, we're going to choose dv to be x. And we have to integrate dv, okay? Which in this case would be the integral of x that would be our v. So, you came up with this equation, and now you have to solve this one. U, which we have cosine of x, v, which is what we integrated dv to, minus the integral of v dv. Oh, sorry, du. As you can see, by choosing the wrong v and the wrong u, the wrong dv, by choosing the wrong everything as in life, things just got a bit more complicated. Yeah. If you see your equation getting more complicated as you go, forget about it. and start by the beginning. Choose a different u, choose a different b. It's fine. You do that all the time in math. So right now we're gonna choose u to vx because we want the derivative of u to be easier than the derivative of the other one. What is the derivative of u? It's simply 1. Don't forget to add dx. I forget that a lot. It usually don't matters, but you know professors, they want their dx or d terms, whatever. For dv, we're gonna choose the other one, cosine of x. Remember, to get v, we wanna integrate dv, which in this case will give us sine of x. I didn't do the integration because it's easier for me to remind myself of what it is, but if you want to do it, you can do it manually. Once we have our base values, we just replace and plug into that formula. We solve it, we have our integral. Let's do it. Take note that I forget a lot, but probably, I hope, you won't forget it. The constant of integration. In every integral should have it. Plus c. Because when we are deriving things, for example, when we derive x squared plus 2, this thing is gonna get lost. Because as you know, the derivative of that would be 2x. That's it. What happened to the 2? It became a 0. So, the plus c takes into account the term that we lost. So it's usually the best idea to include it. I usually do it in my homework because I remind myself that I want an A, but I forget sometimes. It happens. Coming back to our thing, integration by parts, we're gonna try to plug and chug the integral and solve it. So, the integral of u dv, we decided u equals x and dv equals cosine of x equals u times v. In this case, u is x, v is sine of x, minus the integral of v du, v sine of x du. This makes our job a lot easier. It's just dx. Let's solve it. Ta-da! I did it easily because I do math, I do calculus for a living, for studying, for university, but if it's your first time doing integration, it's gonna take a while. Don't worry, it takes time. So our final result would be that the integral of x cosine of x dx equals this is really important as well. Remember, we have minus the integral of sine of x dx. There, we just integrated the integral of sine of x dx. Forget about your sine, you're toasted. Don't forget it. Remember it as if it's your life depended on it. Our minus sign and the result. Minus cosine of x. Our final result is the following. Our final result is the following. Oh, come on! Our final result is the following. So you may be wondering, what happened to the negative sign? Remember rules of signs and things? Minus plus minus, it's minus. But minus times minus is positive. If you want a video on that, leave a comment down below. But it's usually easy. This video was supposed to be quick, fast, and efficient. So it's an introduction. Don't expect to be a master by the end of this. So in short, the thing that you have to remind yourself about for integration by parts is just the formula. Remind yourself about that, and you'll be golden in your tests. It might take some time to get used to and some practice. I know it did. I know it still does. But it's pretty neat. And if you like this video, remember to follow me at Albert J. Black in social media subscribe to this channel, and leave it a like down below. Why not? This video is cool, and you are cool too if you do a like and a subscribe button down below. There you go, guys. Have a good one. The best of love to you all. Take care.